But all right, awesome. So we have some tests. We've done mocking. We have a gas snapshot. We're of course going to want to add a readme.md at some point. Later on, if you want, you can just copy from my readme in here. We've only got a couple of things left to do. These are the 4 things we have left for this project. Just do a proper readme, a couple integration tests, where we're going to programmatically verify our contracts inside of Foundry, and then we're going to push our code up to GitHub. And this we absolutely need to get here because this is how we're going to build our portfolios. And so, and how other people are going to see, oh my gosh, they're such awesome engineers. So let's push through the rest of these. So for a README, you can use my README here as an example of what a good README should look like. A README in your contract in your GitHub should really explain, hey, what your code actually does, and then how to actually do it, right? So you'll notice in most of my READMEs, I have a getting started section, which tells you the requirements that you need to actually run anything. We have a quick start, which starts with a git clone, which I'll explain in a little bit, and then how to actually use it. If you look up best README in Google or Brave Search or whatever you want to use, there's some fantastic templates to write amazing READMEs. Okay, cool. That's done. What's next? All right, integration tests. So if we want to actually interact with our contract here, right now, we don't have a programmatic way to do that, like funding and withdrawing. And in our tests here, we tested funding and withdrawing, but we didn't test funding and withdrawing using the methods that we're actually going to use to do that. When we actually call funds and withdraws, we're probably going to do cast, send, and then, the address, and then fund or whatever, and the value and everything. Or we're going to do it with Forge script, right? Let's do it with Forge script so that we can have a reproducible way to actually fund and withdraw. So in our scripts section, we're going to create a new file called Interactions.s.sol. And in here, we're going to have all of the ways we can actually interact with our contract. So we're just going to make a fund script and a withdraw script. So let's go ahead. SPDX, license identifier MIT. Thank you, GitHub Copilot. We're going to do pragma solidity 0.8.18. We'll do a little caret. Do contract interactions. This is going to be a script. So we'll say is script. We're going to import script from Forge std script.sol. We're going to spell contract correctly. Okay, great. Excuse me, not interactions. We're going to call this fund.me. So this is going to be our script for funding the FundMe contract. We're also going to make a contract called withdraw FundMe. So this is going to be our Foundry script for funding. This is going to be our Foundry script for withdrawing. So in here, as we're going to do function run, it's going to be external. And this is where we're going to put the code to actually do our stuff. Now, something that's important though, is we are pretty much going to want to fund our most recently deployed contract. So what I typically like to do is I have a script. I've got a tool called Foundry DevOps that I use to actually grab my most recently deployed contract address. There's some other Foundry DevOps tools coming out, and I will have a link in the description to the most up-to-date one that you should use because I'm probably not going to maintain this moving forward unless a lot of people use it. This package helps your Foundry keep track of the most recently deployed version of a contract because I'm pretty much only going to want to run fund on my most recently deployed contract. So to work with this, we're first going to install it, and you'll see why this is important very soon. We're going to run forge install chainlink.org -foundry devops -no -commit. Great, we're going to install that. Now what we can do is say import DevOps tools from, and we'll just grab it right from the package. So we'll say Foundry DevOps /src/DevOps tools.sol. And in here, in this library, Foundry DevOps, SRC, it has this script called get recent deployment.sh. So in Foundry, you can actually run bash scripts or other types of scripts from Foundry. But in order to do this, in your foundry.toml, you need to set FFI equals true. Now, a word of caution here. If you set FFI to true, this means that you're going to allow Foundry to run commands directly on your machine. More often than not, I recommend you try to keep this off as long as possible. But it is important for us to know how it works and how we can use it for something like this to get our most recent deployments. So this Foundry DevOps tool, you just install it. And then to use it, it has this DevOps tool that get most recent deployment that we can use to get the most recently deployed version of a contract. This way, we don't have to pass the Foundry contract address that we want to work with every single time. So the first thing we do in our run function is we can say address most recently deployed equals DevOps tools dot get most recent deployment. And we pass the name of the contract, which is going to be Foundry, and the block.chain ID, so it knows what to do. The way that this works is it looks inside of the broadcast folder based off the chain ID, and then just picks this run latest and grabs the most recently deployed contract in that file. So now that we have the most recently deployed contract address, we can just call fund on this most recently deployed address. Now I'm actually going to separate where we actually do the funding into its own function, and you'll see why soon. So I'm going to say function fund me address most recently deployed. I'm going to make this public. Say vm.start broadcast. And in order for us to actually do anything with the fundme contract, we're going to need to import fundme from ./src/fundme.sol. We're going to wrap this most recently deployed address in here. We're going to say .fund, and I'm going to create a uint256 constant send value equals 0.01 ether. Send value. We're going to fund value is going to be send value. Close that off here. vn.stop broadcast like this. And we actually have to typecast most recently deployed as a payable because we're going to be sending value here. But then I like to do a little console.log, and we'll say funded fund me with, and if we do %s, we can actually populate that with send value. And so since we're using console, this is also located in the script.md, so we can import console from there. And I just like to see that, hey, this actually went through. So we have this fund me, and instead in our run, we're just going to say fund me with this most recently deployed. So we're going to have our run function call our fund me function. Whew, big mouthful. So this is what we're actually going to do to fund our fundme contract. So if I pull up my terminal, I would run forge scripts Interactions.s.sol, and I'll put this little colon here to pick the contract. So we have fund me, and we also withdraw fund me. I'm going to pick the fund me here, and then I would do --rpc URL, blah, 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 --private key, blah, blah, blah. And that's how it actually call fund me. So that's how I would call it as a script. And we want to test this as well. And this is where our integration tests are going to come into play. So integration tests are when you test a lot of your interactions, you test combinations of systems. And I usually like to separate my integration tests and unit tests in different folders. So I'm actually going to go ahead and do that. I'm going to create a new folder called unit. I'm going to take this fund me test.t.sol, stick it in here. And since we did that, we need to update some of our imports because they're now in different areas. I think I did it right. If I do forge test, am I doing everything right? I'm kind of like halfway done with a bunch of stuff. Yep. Okay, cool. Test pass. That's great. And I'm also going to make a new file called fundme test integration.t.sol. And I'm going to copy a lot of this from the fundme test, paste it in here. Fundme test integration, or we can also just call this interactions test.t.sol. So maybe in here, we'll have our function setup, which is going to be external. We're going to say deploy fundme, deploy equals new deploy fundme. So we have deploy fundme, great. And then same as the test, we're going to do this bit here. So I'm just going to paste that. Let's copy a lot of this actually. Change the name here. Cool. So we copied most of this. let's change this name to interactions. Test is test. All the setup is the same. The only difference is now we're going to say function test user can fund and user can fund public. Instead of funding directly with the functions, we're going to import fund me from /script/interactions.s.sol. And in here, we're going to say fund me equals new fund me. Isn't that wonderful? Stay with me here. I swear this makes sense. And then we can do fund me dot fund me with the address of fund me. And this is why I separated those scripts out, right? Because I can't run with this. I want to run fund me and be able to add my own address in here. So we're testing this specifically to make sure our funding works. And we can actually go back to our test and do something similar to when we did the fund. We can make sure that they get added to the list of funders. We could do something like this in our test, paste it in here. Test user can fund interactions like this. And we'll run this single test, forge test-m, paste that there. Boom. Oh, assertion failed. Oop. And let's actually put these VM broadcasts in the run. That's actually where we're going to be doing them. Like that. We want to put the broadcast down in the run, not up here. And I should probably have deal user. Just do 1E18. And this is where we're actually going to test that script, but let's also make the withdraw. I'm actually just going to cheat a little bit. We're just going to copy pretty much all of this, paste it in here. Instead of fund me, we're going to call this withdraw fund me. And instead of fund, we're going to call withdraw. No value. Close this off. Close this off. And instead of fund me, we're going to call withdraw fund me. And now in our test, we're going to say, first, we're going to call fund me with the address fund me. Then we're going to say, withdraw fund me equals new withdraw fund me. We're going to do withdraw fund me, address fund me. Stay with me. And we're just going to assert address fund me dot balance equals 0. Stay with me here. So we need to import withdraw fund me from interactions as well. Excuse me. What we're going to do is we're going to fund using our scripts, and then we're going to withdraw using our scripts as well. So let's go ahead. Let's run this. Forge test-m, paste that in here. Looks like we got a revert. Let's do -vvvv. See what's happened. Oh, looks like we are indeed out of funds. Oh, and in the withdraw fund me, we need vm.start broadcast. And then of course, vm.stop broadcast like this. Now let's run this test here. And we get it's passing. Whew. Okay. So I know we wrote a lot here, and I know I went through that kind of quickly, but feel free to pause and take a minute to understand what we did here, right? So now we can run forge script interactions.s.sol fund me, and then our network information here, so that we're always calling the fund the way we want to call it. And then we created some integration tests, which kind of bring it all together. And then we did the same thing with withdrawing money as well. And now we've got a huge suite of tests that we can test all at once with forge test. And we see we pass everything. And then we also can do forge test --fork URL, Sepolia RPC URL, or even mainnet RPC URL. And we see everything passes here as well. So even when we're pretending to deploy to a live network, everything is passing. Awesome.